Hello, dear students. In the last period, we have studied about carbon. So we know that carbon has got atomic number 6, atomic mass number 12. Its electronic configuration is helium 2s2 2p2. So we represent the electronic configuration in this manner, that in 2s we have 2 electron and in 2p we have 2 electron. Now what happens after absorbing some energy, carbon get excited. This is the excited state. When this carbon get excited, one electron from 2s goes to 2p, and thus a new kind of electronic configuration is formed. That is how we represent it in this manner. Am I audible? बच्चों,
Yes,
क्या आप
sir.
मुझे सुन पा रहे हैं और क्या आप स्क्रीन भी देख पा रहे हैं जो मैं लिख रहा हूं वो?
Yes, sir.
Okay. See, now onwards I will not be making the screen to stay state. मैं कुछ लिखता रहूंगा या कुछ ना कुछ बोलता रहूंगा, तब कुछ ना कुछ मेरा पेन चलता रहेगा. तो अगर थोड़ी देर भी ये बंद होता है, you got to inform me, okay? So this is how you know you have one electron in 2s and 3 electrons in 2p now. Now this one electron in 2s and 3 electrons in 2p, they undergo hybridization. There is possibility of hybridization. So now what kind of various hybridization possible, that is what we really need to understand. So my dear students, let us have these orbitals with us. Each orbital has got one electron, and when these orbitals undergoes the hybridization, there are three types of hybridization which is possible. So let us understand these various types of hybridization that is possible in this case. You can see when this all four orbitals, this is 2s, this is 2p, this is even 2s and 2p, this is 2s and 2p. We are talking about carbon. Please remember that we have this carbon in the excited state. So this carbon, when all the four orbitals, they combine with each other, they gives us sp3 hybridization. Suppose one orbital does not take part into it, then we'll get sp2 hybridization. And if only one s and one p orbital only take parts into hybridization, then we have sp hybridization. So here, my dear students, we have various types of hybridization that takes place. Now, you have studied this hybridization into the previous classes, and you have come to know that our methane CH4 has this kind of hybridization. But if you think about CH2 double bond CH2, which is known as ethene, ethene has sp2 hybridization, and if you have ethyne, then it has sp hybridization. What do we understand here? That if we have methane, then this methane has got four equal type of sp3 hybrid orbitals, and thus we can have a tetrahedral shape. Let us understand the tetrahedral shape, my dear students. This is where we truly understand about the tetrahedral shape. So here you can see that we have a tetrahedral shape. Here, my dear students, what happens? There is a plane of this carbon. This carbon and this carbon are bonded. Here we have the hydrogens. What happens? This electron, which is not taking part into this formation of ethene, the same plane, this orbital remains above and under the plane. So now you can represent this orbital in this manner. This is how it happens. So now you can easily understand, my dear students, that when this p orbital, or when we have the sp2 hybridization, this is what it happens. So you can see that there is an electron cloud above and under this plane. But dear students, when it comes to the ethine, where we have the sp hybridization, what we find is that we have this bonds. We have the bonds of this carbon and hydrogen in the same plane, and we get the linear shape. Here we call this shape as a planar or triangular planar. Now what happens? We have two different orbitals. First orbital is in this manner, we can represent it. And there is the overlap, and you can see here there is a cloud of electron above and under the plane. This is what it happens. If we call this as an x-axis, then this is what it happens into the y-axis. Now, my dear students, we still have one more axis left with us, which is a z-axis. So in the z-axis, what happens? This carbon and this carbon have got, see, we have utilized this. We have represented this electron with the red, and this electron we have been representing it with the green color. You can see that this carbon and this carbon, they undergoes the hybridization, or sorry, sideways overlap, and this is how you can have the two pi bonds which are possible. Dear students, do you understand it? Do you have any question to ask for this explanation? Have you understood it? Please
Sir,
reply
there
fast,
is
dear students, so that I can give you the answer of your questions, or we can move forward.
Sir, please re-explain it.
What should I re-explain, beta? What you could not understand, can you tell me?
CH3 bond enthalpy, last one.
Okay, so that's what I need to explain you once again, right? CH1, this one or this one? Name the compound.
Ethene.
This one? Spelling Ethyne? Can you speak the spelling?
Yes, sir.
What, yes, please tell me the spelling.
Ethene.
Okay, let us understand it. So see, the child is not able to understand the ethine one. Let me explain it once again. See, this is carbon. This carbon has got some of the orbitals with it. So, you know, it undergoes the sp hybridization, and forms bonds here. Now, when we have carbon and when carbon undergoes the sp hybridization, we have the various orbitals that have the various electrons. So in 2s and 2p, we have all orbitals has got one electron in the excited state of carbon. Now what happens? These two orbitals, they do not take part into the hybridization. Thus we will get sp hybrid orbitals, and with the sp2, this carbon has got two sp hybrid orbitals which it combines and gives us this. So we have this bond C. We have this bond. Here we have C, then this bond C, then this bond H, and this bond H. That is what we have represented here. So here we have, my dear students, we have C bond C, then here we have hydrogen, and here hydrogen. Now these two orbitals on both the carbons are available. These orbitals are perpendicular to each other. These orbitals are perpendicular to each other. Do you understand the meaning of perpendicular?
Yes, sir.
Okay. So you can see that this is your x-axis. You know, the various axes are perpendicular to each other. They make the 90 angle. So now what happens if this is the x-axis, then one of the orbital is available in this manner. And there is an axial overlap above and under the plane. Till this, do you understand?
Yes, sir.
Okay. Now see, this is the y-axis. Now we want to arrange the orbitals into the z-axis. So this is what it is going to be, z-axis. So now on each carbon will have some of its orbital, or this another orbital. See, this orbital I am talking about. This is what we have represented with the red. Now this one I'm going to represent it with the green one. So there is an overlap into z-axis. You can see this overlap which I have made, stronger. So this is the two type of overlap that takes place. This overlap, my dear student, this overlap takes place into the z-axis. This overlap takes place into the y-axis, and this is your x-axis. Once again, understand? If you really want to understand it this way, so that you will understand it better. See, you have a plane over here. This is the plane I'm talking about. So, your x-axis is in this manner. I'll show you your x-axis. Your x-axis goes this way. This is your x-axis. Now what happens? You have the y-axis. So, let me show you the y-axis. This is what it is going to be, your y-axis. I hope it is understand. This is y-axis, and this is what it is going to be, your z-axis. Your z-axis starts from this and comes out. Now do you understand the various axes? Maitri, I'm asking
Yes.
you. Okay, so this
Yes,
is
sir.
x-axis. You can see that all these three bonds, all these are present on x-axis. Now on the red part, which is on the y-axis, you can see here, you can compare it with this. This is how you can understand about the y-axis. See this y-axis, and this is what it represents, the z-axis. This is your z-axis. So in 3 dimension, you can understand that these orbitals are arranged perpendicular to each other, and as these orbitals are arranged perpendicular to each other, each orbital do the overlap. So this sp hybrid orbitals, they do overlapping into the x-axis. But these two orbitals which are not overlapping, which are not taking part into the hybridization, they are overlapping either into the y-axis or they are overlapping either into the z-axis. And that is how we can form the three other bonds here. So this one bond is formed, then we have one we have shown with the red one, the another one we have shown with the green one, and thus there is triple bond between these two carbon. And this is how the ethine is formed. Is it clear now?
Yes, sir.
Okay, that's going to be wonderful. So, so you can understand the various types of hybridization now, my dear students, that we have the various types of hybridization, like we have sp3 hybridization, we have sp2 hybridization, we have sp hybridization. We have seen that methane has got sp3 hybridization, CH2 double bond CH2 has got sp2 hybridization, and CH triple bond CH has got sp hybridization. So we can say now we should understand that if all bonds in carbon compound are single, then carbon undergoes the sp3 hybridization. Please remember that then carbon undergoes the sp3 hybridization. If at least one multiple bond, one pi bond is present, then it is considered as a sp2 hybridization. But if at a time carbon undergoes or carbon make two pi bond, if carbon make two pi bonds at a time, then the hybridization is going to be sp. This is what we can easily understand. Now I'll show you one very interesting case of this sp hybridization. You know, we have carbon dioxide. In this carbon dioxide, carbon undergo sp hybridization, and at a time it makes two pi bond. You can see here. So first of all, I think we should know what is the sigma bond and pi bond. So my dear students, you are aware that in methane, all the bonds are single bonds, and all these bonds are known as the sigma bonds. These are all sigma bonds, and these sigma bonds, are formed by using the various types of hybrid orbitals. Now, if you look into the another case where you have CH2 and you have double bond CH2. So this is what it happens, and this is what it is known as ethene. In this particular case, my dear students, these all are the sigma bonds. But we have this multiple bond between the carbon, which is known as the pi bond. So this is the pi bond. But in case of, my dear students, if we look into the ethine, molecule, we would realize that in ethine molecule, we have triple bond between the carbon. And thus we can say that these are the sigma bonds. This is sigma bond, this is sigma bond, this is sigma bond, but these two are the pi bonds. So now you can easily understand about the sigma bond and pi bond. Do you understand it? Do you understand about sigma bond and pi bond, dear students? Do you
Yes,
have any
sir.
doubt in sigma bond and pi bond?
Yes. No, sir.
Okay, now let's move forward and understand. I'm going to give you one compound. Suppose you have a compound. This compound is this: CH, triple bond C, CH, double bond, CH, CH3. We just need to find out how many pi bonds and how many sigma bonds are present. How many pi and sigma bonds are present. So please understand, my dear students, that this type of compound we will have to turn it into the a complete. So let us find out how many carbon: 1, 2, 3, 4 and 5. So we will have a chain of 5 carbon. This carbon is bonded with 3 hydrogen. This carbon second, or let's say fourth carbon, undergo the double bond between the third and fourth. So there is the double bond that we can represent, and the first and second carbon has got the triple bond, so we can put it there, and then we can write it this way. So this is CH, triple bond, then C, this C has got all its valency complete. This carbon, third carbon, has got 1 hydrogen. The fourth carbon also had got 1 hydrogen, and this is what it happens. So now this is how you can see this, and looking into this, we can find out the sigma bonds and pi bonds. So let's have a look to this. Let us find out the number of sigma bond and pi bond. So let me show you the multiple bonds first. So this is what it is, the pi bond. This bond is going to be the pi bond, my dear students. This is also a pi bond. This is even going to be pi bond. Now rest of the other bonds are sigma. So this is sigma, this is sigma, this is going to be sigma bond, this is sigma bond, sigma bond, sigma bond, sigma bond, sigma bond, sigma bond, and sigma bond. So even we can bifurcate and we can understand it some other way. First of all, how many pi bonds? So you can see that in here we have 3 pi bonds. We have 3 pi bonds. How do we have 3 pi bonds? So if we give the numbers, then 2 pi bonds, 2 pi are present between C1 and C2, and 1 pi is present between C3 and C4. So this is how you can understand. Then how many sigma bonds? So here we have various types of sigma bonds. First, let us find out the number of sigma bonds. 1, sigma 1, sigma 2, sigma 3, sigma 4, sigma 5, sigma 6, sigma 7, sigma 8, sigma 9, sigma 10. So total sigma bonds are 10. Out of this sigma bonds, how many are CH type of sigma bond? How many are CH type of sigma bonds? That is what we can easily identify. So you can see this is sigma CH bond. So 1, then we have this 2, then we have this 3, and 4, 5, and 6. So we have 6 CH sigma bond. Then we need to find out how many CC sigma bonds are present. So we can find out CC kind of sigma bond. So let me try it out with the CC sigma bonds, my dear students. So let us find out the CC sigma bond. This is 1, sigma 1. Then we have 2, then we have this 3, then we have this 4. So we have 4 CC sigma bond, and that is what it gives us, the total 10 sigma bonds. So if you are given any compound, my dear students, from this particular compound, you can easily find out the number of sigma bonds and number of pi bonds. Very easily, it is easy for you to understand this. Now, my dear students, let us find out the type of hybridization that we can have. So to understand the type of hybridization, we just want to know about the type of hybridization. Type of hybridization in a compound. So when we want to find out the type of hybridization in a particular compound, we need to know that if there is one double bond, or if carbon is making double bond, or if an element is making double bond, then we have one pi bond and sp2 hybridization. If all bonds are single, then sp3 hybridization. And if a carbon is going to make 2 pi bond at a time, it is going to be sp hybridization. So let us take the first example of CHCl3. In a compound, we just need to find out it for carbon. So we just need to find out for carbon. So here the first example that we are going to study here is the example of CH3Cl. CH3Cl. You can easily understand, my dear students, that in CH3Cl, this is the kind of structure which is going to give us all the sigma bonds or all the single bonds, and that is why the carbon here is present as sp3 hybridized. Then, my dear students, we have the next example. Our next example is CH3 twice CO. This CH3 twice CO, we can represent it in this manner: C double bond O. Then we have CH3 and CH3 around it. This is how we represent. So my dear students, here you can see that this carbon has got double bond with oxygen. So this is what it is going to be, pi bond. This is what it is going to be, sigma bond. All the other bonds are single. So this carbon does not make any kind of double bond, and that is why this is sp3 hybridized. This carbon definitely is going to have made the double bond, so it is sp2 hybridized, and this carbon is sp3 hybridized. Now if we give them the numbers, this is C1, this is C2, and this is C3. So we can write that C1, C2, and C3. This our C1 has got sp3 hybridization, our C2 has got sp2 hybridization, and our C3 has got sp3 hybridization. This is how we can understand. Now let's look at the third example. Suppose we have CH3CN. CH3CN, this is the third example. So CH3CN, we represented it in this manner. This is CH3. Then we have C and then triple bond N. Now you can see that this carbon has made triple bond with the nitrogen. That means this carbon, can you tell me what is the hybridization of this carbon? Carbon with the triple bond? I need the answer from you.
SP.
Very good. So this carbon is going to be sp hybridized. What could be the hybridization for this carbon? I need the answer from you, my dear students.
sp3.
Very good. So C1 will have the hybridization. What should I write here? Come on, speak up.
sp3.
Very good. And what
sp3.
should I write for C2?
sp.
Very good. Now we have the fourth example. The fourth example is HCONH2. HCONH2. This is how I represented this H. Then we have C, then double bond O, then N, and then we have H and H. Please find out what is the hybridization for this carbon. You need to tell me what is the hybridization for this carbon. Tell me, what is the hybridization for this carbon?
sp2.
You are right. Can you please repeat it once again?
sp2.
Beta, please be a little louder.
sp2.
Thank you. Let's move to the next question. The fifth question that we have is CH3CH double bond CHCN. CH3CH double bond CHCN. Let me represent this. 1, 2, 3, 4 carbon, that is what we have. Let me give the numbers. This is 1, 2, 3, and 4. This fourth carbon is bonded with nitrogen with the triple bond. This carbon has got 3 hydrogen. Between C2 and C3 there is a double bond, and each carbon is bonded with hydrogen. Now we have the 4 carbons, my dear students. This is C1, this is C2, C3 and C4. You need to tell me C1, C2, C3 and C4. You need to tell me what is the type of hybridization that we have in C1. Come on, tell me. The hybridization in C1.
sp3.
In C2. Come on. In C2. What kind of hybridization is there in C2?
sp2.
Very good. In C3. In C3.
sp.
This is your C3.
sp3,
Please repeat.
sp3,
sp.
sp2.
Yeah, it's sp2 because this carbon has made only one pi
sp.
bond. Yes or no? But if you look into this carbon, it has made a 2 pi bond and 1 sigma bond. So what is the hybridization for C4?
sp.
Very good. It's very easy for you to understand this. So here in this, you will write sp hybridization. It's easy for you to understand if you really understand it in a nice manner. Now, my dear students, we have even more questions to solve. Let us move forward and understand the other example. CH2 double bond C double bond O. CH2 double bond C double bond O. Now I'll write it and you need to do it yourself and then you need to tell me. Then the other example that I have is CH3CH double bond CH2. Then I have C6H6. So this C6H6 I represent it in this manner, my dear students. And each carbon has got hydrogen. Now you need to fast tell me the hybridization for the carbon which I represent. Tell me what is the hybridization for this? Make it fast.
sp2.
Okay. What is the hybridization for this carbon?
sp2,
See, look at this carbon. You will realize that this carbon has made 2 pi bond and 2 sigma bonds. So how many pi bonds this carbon has made? Hello?
sp.
sp bond.
Very good. What is the hybridization for this carbon?
sp2.
sp3.
What is for this?
sp2,
It is CH2 double bond CH2.